Okay, so we're looking at estimating instantaneous rates of change from an equation. So chosen here an equation that you might be pretty familiar with. It's a quadratic. The function is equal to x equals, or x squared. It's like the parent function of quadratic. And we want, this is sometimes a symbol used for the rate of change at x when it's equal to 2. The rate of change is slope. This triangle essentially means rate of change. So if you're looking at change in the y's over the change in the x's, that's the formula of y2 minus y1. It actually doesn't matter which numbers, but as long as you're consistent, as x1, it's the idea of slope. And that's what rate of change is. It's slope. Okay. Now, we could find the rate of change between several different points here. We're going to look exactly at 2. So what we're going to do to figure this out, okay, we're going to change this equation a little. Because we no longer use the letter y here, we're using f at x. So this equation changes a little. And we could write it like this: f at x2 minus f at x1 over x2 minus x1. So exact same equation. Okay. The only difference is instead of using y's, we're using f at x to represent the y values because we don't use the y anymore, the function notation. Okay. So what that means is we need two sets of coordinates. We need a coordinate when x is 1 and then x is 2. And since we're trying to find a rate of change at 2, we're going to use several different values, kind of like on a table, to get closer and closer and closer to it. So let's kind of try to tease this out here. Let's say we use, when the value of x, we're going to slowly get closer and closer to 2. Actually, you know what? I set this up. Let's make this a number line to help us visualize this idea. So imagine I'm at the number 2, and I'm approaching 2. So if I approach it from the left, well, there's the number 1, and I can approach it from the right, which is over here, and the next whole number is 3. Now I could use those values, but they're actually pretty far away from 2 in terms of the slope. So if you're trying to find instantaneous rate of change, you're looking for values that are extremely close to 2. Okay, so instead of using 1 or 1.5 or 3 and 2.5, we're talking things like 1.999 repeated, which is extremely close to 2, or something like 2.001 or 001, or even closer. You can get closer and closer and closer, okay? So the closer we get to 2 and calculate the slope between those two x values, so these are our x values we're going to use, okay? The closer we do this, the more accurate our instantaneous rate of change is going to be, okay? And actually, for this, whether you're approaching it from the left or from the right is the exact same. So we're going to focus on approaching it from the number 3, okay? So what we can do is I can try with these 2 points to start. When x is equal to 2 and when x is equal to 3. And we're going to plug them into the exact same equation, our x squared here. And we're going to find out where those coordinates are, and we're going to find our rate of change from there. Okay? So the first thing you need to do is we've got to find f at the value of 2. Okay? And since it's x squared, it becomes 2 squared, so that value is 4. So what that means is f at 2 is the value of 4. In other words, that's your y coordinate. If we were to make an actual coordinate for this, it would be 2, 4, exactly. The next thing we're going to do is find f at 3. And because it's squared, it becomes 3 squared equals 9. So our coordinate, f at 3 is 9. Our coordinate here is 3, 9. Okay? So now we plug that into our slope formula. Okay? So we'll call this our f2, and we'll call this our f1. Okay? So remember the formula we read was the rate of change of y over the rate of change of x is f at x2 subtract f at x1 over x2 minus x1. Really, it's just slope. Okay, so let's plug them in. Our f2 was 9, so we have 9, and our f at 1 was 4, minus 4, so those are the two y coordinates, right? 4 and 9. And then subtract, x2 is 3, and x1 is 2. So what we find is we get 5 over 1, which is a slope of 5. So in other words, it's saying the rate of change, if we use 2 and 3, or the instantaneous rate of change is 5. And I've quickly over here made an equation that kind of shows you the slope. So the slope is 5. I calculated the y-intercept to help us out visually, but that's where this line crosses 2 and 3. But that's not really instantaneous, because if we go in there, do you see like that big gap between the two? That's creating what is called a secant, okay? And a secant is not the type of relationship you use to find instantaneous rate of change. You want something that's tangent, which means it only touches it once. We can clearly see here that it's actually touching it twice, right? We're getting 2 different touches. So that's a secant relationship. We're looking for a tangent relationship. So we want to use something a little bit closer than that, okay? So let's kind of go down our list. We can use 2.5 if we like. And we're going to use some, I'm going to use a calculator as we go through this, but we already know f at 2 is going to be 4, right? We've already figured it out. So our coordinate is 2, 4. We don't have to do any calculations there. So let's try 2.5 and see if we can get a better slope or rate of change. This becomes 2.5 squared, which 2.5 squared equals 6.25. Okay, so our y value is 6.25. Okay, so our coordinate is 2.5 and 6.25. So we use our formula to calculate. 6.25 subtract 4 over 2.5 minus 2. Okay, that's change in y over the change in x. This is going to become 2.25 divided by 0.5, which is going to double it. 4.5, I think?
Yeah.
Yeah, 4.5. Okay, so now it's saying the slope is 4.5, which is probably a little more accurate. Let's see, I'm going to quickly see if I can build an equation that shows us that. Gone ahead, built an equation again, and this slope is a little better than this one. Still hard to see with how far we're zoomed out here. We can see that's a little closer to being tangent, but it's still a secant relationship. So the idea is we started at 3, went to 2.5, but we want to get as close as possible while doing this, okay? So I'm going to go back, and instead of using something that's really far, I'm going to use something quite close, something like 2.001, okay? So again, we already know our f at 2 is 4. What is our f at 2.001? Okay. So 2.001 squared is equal to 2.001 squared 4.004001. 4.004001. Okay. So we go to find our slope. This is our y value. 4.004001. Subtract our other y value, which is 4. So that's the change in y's over the change in x here, which is 2.001 subtract 2. So now we're using really small decimals. We're going to get 0.004001 over 0.001. Okay, so what is this as a rate of change? Let's find out with our lovely calculator here. 0.004001 divided by 0.001. 4.001. Okay, so this slope, 4.001, and I do need to get a bigger view of this here. It's a little hard to see when we zoomed out. Remember, we went from a slope of 5, 4.5, to 4.001. This is still technically a secant. What number do you think we're getting closer and closer and closer to? 4. The true instantaneous rate of change at this point is going to be 4. Okay, but this one's going to be a secant that's really close. I'm going to try to build an equation one more time for us so you can see. So here's our equation of our line, and it really looks like it's tangent at that point. Like it looks like it's just touching 2.4. But if we zoom in kind of at a micro level here, there it is. It's so small that we really have to zoom in to see that it's still a secant. Zoom in more for it. There it is. It won't let me touch it. It won't let me click it. I guess I zoomed in too much. Oh my. Oh, there it is. Sorry. Okay. Here's our secant relationship. So it is touching it twice. But if you look at our values here on the side, it's at like a very micro level. Very hard to tell. Okay. But again, not truly a tangent. So what we're doing here is we're constantly estimating to find out what it is. This here is the actual tangent equation. The instantaneous rate of change is a slope of 4. It's actually 4 at that point, and I built the equation. I'll zoom out so we can see it. Oh, I need that for it. We were really zoomed in there. There's our actual tangent. So the instantaneous rate of change at 2 is actually a slope of 4 in our question.